and welcome to another episode of X and Y. I received many emails this week from grade 12s asking me about derivatives and first principles and tangents. So first I'm going to explain where the first principle formula actually comes from, and then I'll touch on one point with regards to tangents. Get it? 1 point, tangents. Anyway, let's get straight into it. The first thing to remember is that a derivative is simply a gradient. The only difference is that a derivative finds the gradient on a curve, which is obviously changing all the time, which is why we have a different formula. But let's say it is a gradient. Let's have a look here. If this is the point x, then obviously that is f of x, the y value. And if that is distance h to my next x value, then obviously it's x plus h, and similarly there I've got the function of x plus h. Now if it's simply a gradient, let me just use the gradient formula and see what happens. Right, now obviously x minus x is simply 0, and that is now where our derivative formula comes from. But there's going to be a slight change. You see, this is a gradient between 2 points, so it is a straight line gradient. Now, if I take this yellow line over here, and I start to try and bring it closer to the curve, you'll notice that h, the value starts to decrease. And if I keep on decreasing it, and look what happens there. Now I've got the gradient, that exact gradient, at that exact point. And that has now become a tangent, which we'll get into just now. But basically what has happened here is that my h value has now been reduced to 0, and now I've got the exact gradient of that curve at that exact point. And that's now the whole point. So we change the formula a little bit, and we say, right, this is now the derivative of x, where the limit of h has approached 0. And that is where your derivative formula comes from. So how do I go about finding the equation of a tangent? Now, a tangent is obviously a straight line. So it's going to end up in the format y equals mx plus c. Now, before I get into it, first I want to have a look at this formula over here. Now, it's the gradient formula. Watch what happens when I multiply both sides by the denominator. Look familiar? How about now? You see, the formula for a tangent is simply comes from over here. Now I know that the straight line formula already has y and x in it that won't change. So basically all I need to do here is sub in a y value, an m value, and an x value. So where do I get those from? Well, let's have a look at my function. Let's say for argument's sake this is the function negative x squared plus 10x. If I want the tangent where x is 2, for example, so I sub in 2, the x value, and I get 16. So when x is 2, the y value is 16, right? Now I derive this, and I get negative 2x plus 10. I take the x value because I want to know what is the gradient at that particular x value. We never sub in a y value into a derivative. The second you derive it, y has no more business there. Alright, it's a derivative of x. Anyway, so we take the derivative, we sub in 2 and we get 6. That means we've got a steep positive gradient. When x is 2, we've got a steep gradient of 6. And now it's paint by number. We're going to take this business and we say, right, fine. We multiply out and we write it in the format y equals mx plus c. And there you go. That is the tangent at the point x equals 2. So let me just break it down.
Can't touch this. Yeah, that's how we living, and you know can't touch this.
You are looking for a tangent at a specific x value. All you do is you sub in that x value to get the y value. You take the same x value and you sub it into the derivative to get the gradient. You take the x value, the y value, and the gradient, you sub it into this formula over here, and you simply solve it so that you get it in the format y equals mx plus c.